In this video, I would like to deploy a machine learning model using Docker and TensorFlow serving. You need to already have an understanding of what Docker is and what TensorFlow is and how to build a classifier and train a machine learning model. We write Docker pull TensorFlow serving. It will be taking a few seconds to download the image. Before that, if you require to log into your Docker, you need to write Docker login and just enter your credentials. If you have entered that, then you should not have any problem downloading this TensorFlow image. Now to see our images, we write Docker images and we can see that the TensorFlow serving is available and we have it downloaded. So here I'm right click and create a new folder, which I name it models. I go to this folder and now I'm creating another folder and just name it DNN model, like dense neural network model, or whatever you like to name it. It doesn't matter. Just I'm here name it DNN model. And then I want to give a version to this model because this model is version 1. It's the first trained model. We can train it further with further data or more data and improve our model based on any metric which we want and give it another version. But right now we are having the version 1, and in this version 1 I'm just taking the artifacts which are saved in the protobuf format. I'm pasting them here so you can see that we have an assets folder, we have a variables folder which contains all the variables of our model, and also this is the saved underscore model dot protobuf. TensorFlow requires a config file to serve the models. So we require to create this config file, and for doing that I'm using the Visual Studio Code editor. For doing that I have imported the folder by just opening it from the VS Code and just choosing this folder. So I have chosen already this ML folder, and I can see the models folder in my editor. So if we look into this models folder, we can see that it contains the DNN model and the version 1 in which we put all the assets of our model there. Now we create a config file by writing models.config. But this config file should be outside of this models folder, because this config file, through this config file we manage all our models. So I'm going to the folder and just click here and just cut this models.config and put it in here. So we have this models config, however it's right now empty file. And now I'm opening this models.config in our VS Code and try to complete it based on what we require. For defining the config file, we require to define the model config list, and we write model config list and we write config and we give it a name to our model, and we know that the model which we have created is a saved model.pb file. So just the name is saved model. We require to specify the base path, so we write base path, and the base path on the container we will define it as models, just DNN model. And we also require to define the model platform, and the model platform here is TensorFlow. So I'm defining that, and just the parentheses are closed, so we just save the file and this is a simple version of the model config which we require to serve the model. Now that we have created the config file, we require to create the container and run the image of the TensorFlow. For doing that, we write docker run and we use the port 8501 from our local to 8501 from the TensorFlow. This is the port in which we can communicate with HTTP requests, and we just run the Docker on detached mode. We use the mount type of bind just to mount the model from the local directory to the directory of the Docker containers. So I'm just with this percentage CD, I'm referring to my current directory, and I'm referring to the ML folder. I have created the folder named models, and I put all the models in this models folder, and just I'm referring to my DNN model because I want to mount it to the directory of the container. So I just want to mount it to the models directory and to the DNN folder on the container. So I'm using the mount type of bind, referring to my current directory, which is ML, and my configs reside in mlmodels.config, and I'm mounting it to the target, which is models.models.config. In practice, this we could just use one mount, but here I use two mounts because I prefer to put this config file outside of the models folder. I just give the container a tag name like -t TensorFlow serving. I use also the model config file parameter to refer to the models.config file, which is on the container, and we mount it on the container. So I just hit enter, and if I write docker ps, I can see that the container is now running. To check if TensorFlow now properly serves our model, I would like to use Jupyter Notebook. I have opened the Anaconda prompt and I just write Jupyter Notebook. Now that the notebook is open, I just create a new file here and I just give it a name like testing API. Now I would like to test the deployed TensorFlow containerized API with a Jupyter Notebook, and I would like to use the requests and JSON libraries for sending HTTP requests. So I'm writing import requests and also import JSON, and then I'm defining one data object in Python, which here we are defining the instances. We can actually send different rows or different instances to the TensorFlow API, but here I would like to send one instance of 801. I'm entering the instances which contains the features of the classifier, and this is from a test set. So I'm defining a data object here. Then I'm just converting this Python object to a JSON. So write JSON.dumps data, and then I'm defining a URL. Currently the model is deployed locally, so I'm using the local host as the URL and using the port 8501, and this is the first version of our model, and we are calling to the models. Saved model is the name of our model. Saved model is the name of our model, and then we are referring to different versions. Here we have version 1, and then we want to do a prediction, and we define headers for our HTTP request. We want to send just JSON. We want to send JSON, and now, and also we are receiving a JSON response after sending the post request. And we are, as a data, we are sending the data.json, which contains this instance, which includes all these features. These features, you can find it here in the link which I've shared with you. We want to predict this MPG, and the features are the cylinders and, for example, displacement, horsepower, and so on. So we have 9 features here and 1 label. I here define the one instance with these 9 features and sending a post request. So we hit enter, and then we have the prediction value returned from the API. We are sure now that the API is working and is up and running.